Hi, welcome to Jensen Earth Science. In this presentation, I'm doing an overview of scientific notation. What even is scientific notation? Scientific notation is a way scientists can easily handle very large numbers or very small numbers. An example of a large number will be 1.9 billion, and an example of a small number will be 0.000009. So why change these numbers into scientific notation in the first place? When collecting data, scientists like to save space. In order to do this, we replace the large amount of zeros in numbers and replace them by multiplying by 10 with an exponent. Here is an example of trying to put a large number in a small space. Here's my number, which is 1.9 billion, and here's the space I have to enter this number. And as you can see, 1.9 billion is not going to fit into that small amount of space that I'm given available. To fit this number into my space given, I need to show the number in scientific notation. So to change 1.9 billion into scientific notation, I first want to count how many times I will move the decimal in order for the decimal to be behind the first digit of the large number. First, I'll move the decimal to behind the first digit of the number. So here's my decimal all the way at the end. And now in order to change that to be behind the number 1, I'll have a new number and a new decimal. So my new number is actually 1.9 and my decimal is right behind 1. So how many times did I have to move this decimal? So I moved it once, 2 times, 3, 4, 5, 6, 7, 8, and one more time, making that 9. So I moved the decimal 9 times. 9 will now become my exponent when I multiply this number by 10. So I'm going to keep my 1.9, but I'm going to get rid of all the other zeros. So after this, I will multiply by 10 with my exponent being 9, and the number will finally be 1.9 times 10 to the 9th. As you see, our exponent was 9 due to the 9 times that we changed the decimal. So now 1.9 billion becomes 1.9 times 10 to the 9th. So back to the first slide, as you can see, my 1.9 billion will now fit into this small space that we were given. When I have a very small number, it is the same process, but instead my exponent when multiplying by 10 will be a negative number. So if I start with that original number, 0.000009, I move the decimal to just after the last digit of the number. 0.000009 is actually going to become just 9. So it's the same process. I count the number of times the decimal moved, and I'll use that number as my exponent when I multiply by 10, but as a negative exponent instead because it's a small number. So I moved it once, twice, 3 times, 4, 5, 6, and one more time, 7. I moved my decimal 7 times. So 0.000009 will now become 9 times 10 to the negative 7. And it has a negative exponent because it's a smaller number. I hope this was helpful. Please feel free to check out playlists I've created on the same topic as well. And have a great day.